Hello, this is topic 4-1 on relations and functions. So this is broken into several parts. Our first part is on relations, and so a relation is just a set of ordered pairs. Okay, it's got x values, it's got y values, and they are somehow related. And so we've got different ways of describing them. We can just make a list of ordered pairs. Bam. We can draw a graph. So we've got a graph. On our graph, we've got some plots pointed. That will tell us it's a relation. We've got a mapping diagram, and how we read this is there's a point at 0, -2, 0, +2, 3, -1, 3, +1, and 4, 0. Same points that we are given up here, just as the graph is the same points that were given up here. We can also have a table where I list my x values and my y values. And so I have a 0, -2, a 0, 2, a 3, -1, a 3, +1, and a 4, 0. Again, I could have got them from here, here, or here, because all of this is the same. And then we have equations, and the equation for this particular one is that y squared equals 4 minus x, where x is 0, 3, and 4. And so all of these are different ways to describe relations. Now, one thing that's important to know about relations is domain and range. So the domain is your input values, or your x values, and the range is output or y values. So the domain and range of above, domain, I'm going to pull my x values, and I have 0, 3, and 4. And notice I've surrounded them with this curly brace, as you can see up here. I've used to define my domain. I'm going to do the same thing for my range. And my range, those are my y values. And so I have -2, +2, -1, +1, and 0. And so that's my range. Now, I want you to notice that I didn't repeat the numbers ever. Even though 0 showed up twice, I only wrote it once in my domain. And so that's important. We only want to write each number once. Okay? Now that's once in the domain and once in the range. Let's go ahead and move on to part 3. In part 3, we're talking about functions. Well, functions are a special type of relation, and they're the type of relations that we usually talk about most often. And that means that each x value corresponds to exactly one y value. No x coordinates are used more than once. And then we have some names. X is our independent quantity, and y is our dependent quantity. And we say that the value of y depends on x. So let's go ahead and put this into practice. My domain, well, I've got 0. That's another 0, a 3. That's another 3, and a 4. For my range, I've got -2, 2, -1, 1, and 0. And none of those repeated. So is this a function? Well, my answer would be no, because 0 repeats and 3 repeats. And these are both repeating in x. I don't care if it repeats in y, I just cannot allow it to repeat in x. So let's take a look at number 2. Well, my domain is 1, 2, 3, and 4. I'm just pulling my x values. And my range is 2. I've already got the 2, 1, and I've already got a 1. And so is this a function? That would be yes, because y values can repeat. All right? X values cannot, y values can. All right, now let's take a look at number 3. Well, my domain would just be 1 and 2. Because these are my x's and these are my y's. My range would just be 3 and 4. And now I wonder, is this a function? And because that 1 repeats, it's a no. And moving on to problem number 4. My domain is -5, -4, -3, 0, and 3. And my range would be 0, 3, 4, and 5. And again, we don't need to write that one down again because we've already got it once. And the question is this a function? Yes. All my x's are different. So that's domain, range, and functions. Let's go ahead and move on. Here's another way that we can determine if it's a function. It's called the vertical line test. And so I'm going to take my pencil. It's going to go straight up and down, vertical. I'm going to run it across my graphs like this. And I'm going to look to see if my pencil ever crosses the graph more than once. And so if I look over here, yes, it passes because my pencil never crosses that graph more than once. Well, there's a vertical line, and it crossed in 2 places. So that would be no. And then I look over here, and if I drew a vertical line through those 2 points, notice that that did not pass the vertical line test. Now the vertical line can be anywhere on your graph. Alright, mine just happened to be in both places, but I could draw a vertical line over here and it still fails. So, vertical line test is very nice. If it's already graphed, you can very quickly tell if you have a function or not based on that. And now we're talking about part 4, which is function notation. Well, function notation is just a fancy way to say that y equals. And so f of x equals 2x plus 3 is the same thing as saying y equals 2x plus 3. It gives us the benefit of it names the function. And you can specify x values. So let's take a look here. F of -1, all we do is we rewrite this but we replace x with negative 1. So this would be 2 times negative 1 plus 3. Well, that would be negative 2 plus 3, which is just 1. And that's all we need to do. Let's go ahead and try this on 5 and 6. I just replaced this x with 10. So 5 times 10 minus 1 is 50 minus 1 is 49. And over here, I replace the x with a negative 3. 2 plus negative 3 squared. Now, notice that the negative 3 is in parentheses and the squaring is outside. That is so when you put this into your calculator, you don't mess it up. So if I put 2 plus parentheses negative 3 squared, that's going to give me 11. However, if I did this without the parentheses, it would give me a negative 7, which is wrong. So make sure that you always include the parentheses when you put this into your equation. One more page where we're just going to do some more on domain and range. It's very important that you understand these. So I'm going to pull my domain from this graph. Because I have individual points, I need to mark them individually. This x value is 1, 2, 3, 4, 5, 6 left, so that would be negative 6. This one is 3 left, so that would be negative 3. 1 left, so that would be negative 1. That would be 2 right, so it's 2. And 4 to the right, which is 4. And you already noticed that I have failed my vertical line test. And that would be because of these 2 points right here. But now let's take a look at our range. Well, this one is 3 below, so that would be negative 3. 2 below, so that would be negative 2. On the axis, so that would be 0. 1 above, so that would be 1. And 1, 2, 3, 4, 5 above. And they both happen to share it, so I just need to write the number 1 time. And so that's domain, range, and function all at once. Let's go ahead and talk about number 8. Well, number 7 and number 8 differ. If you'll notice, this has individual points, and this is a line. That's because this is discrete data, and this is what we call continuous data. Because this exists only exactly on these points, and this exists everywhere from here to here. That's the difference between discrete and continuous. Now to find here, it's going to be a little more difficult. I have to write an inequality to represent my domain and range. Domain has x values. And so my smallest x value would be 1, 2, 3, 4, 5, 6 to the left, so I'm going to write negative 6. And my biggest x value is 2 to the right, and so I'm going to put a 2. And x is between these, so I'm going to put some less than signs. And now I'm going to look, well, that is filled in, which means it can equal negative 6. And that one's filled in, which means it can equal 2. And now we do our range. Well, my smallest range value is 3 below, so that would be negative 3. My largest y value would be 1, 2, 3, 4 above, so it would be 4. Again, I go with the less than signs. Because this circle is filled in, I get an equals bar. And because my biggest circle is filled in, I also get an equals bar. I now try a vertical line test, and it passes. So yes, it is a function. And now for our last example, it's very similar to number 9. So I'm going to start off the same way. My smallest x, way over here, is 1, 2, 3, 4, 5, 6 to the left. And my biggest x is 1, 2, 3, 4, 5, 6, 7, 8 to the right. Even though this is higher, it's left, so this is a smaller x. And even though this is lower, it's to the right, that means it's a bigger x. Now let's look at our y values. My smallest y value is 2. And my biggest y value is 1, 2, 3, 4, 5, 6, 7. Now, even though this is to the left, it is up high, and so is my biggest y value. Even though this is off to the right, it's down low, and so it is my smallest y value. And does this pass the vertical line test? Yes. And so this was a rather long set of notes, had 4 different parts. Make sure to go over those that you actually fully understand them to work on your assignment. Good luck and have a good day.